At first, a teacher pinned 22 paper hearts and 2 paper stars on 2 different boards in the classroom. Then, each student pinned either 5 paper hearts or 8 paper stars on the board. In the end, the number of paper hearts was equal to the number of paper stars on the boards. Find the smallest possible number of students in the classroom. We use the method of listing. List the number of hearts and stars until they are equal, starting with 22 hearts and 2 stars, because they were done by the teacher. For each heart, add 5. For each star, add 8. 2 plus 8, 10. 10 plus 8, 18. Plus 8, 26 is more than hearts. Let's move to the hearts. 22 plus 5, 27 plus 5. And we arrive at 42, equal number. How many students pin hearts? Let's count. This is done by the teacher. 1, 2, 3, 4. 4 students pin hearts. How many students pin stars? 1, 2, 3, 4, 5. How many students were there? 4 plus 5 equal 9. At first, a teacher pinned 15 paper hearts and 11 paper stars on 2 different boards in the classroom. Then, each student pinned either 3 paper hearts or 5 paper stars on the boards. In the end, the number of paper hearts was equal to the number of paper stars on the boards. What is the number of students if the equal number of hearts and stars is between 25 and 40? We use the method of listing and arrive at 21. They are equal. But 21 is not between 25 and 40. What do we do? We continue listing. Now we arrive at 36. 36 is between 25 and 40. So we stop here and count the number of students. 1, 2, 3, 4, 5, 6, 7. 7 students pin hearts. 1, 2, 3, 4, 5. 5 students pin stars. So the number of students is 7 plus 5 equal 12. At first, a teacher pinned 8 paper hearts and 5 paper stars on 2 different boards in a hall. Then, each student pinned either 3 paper hearts or 4 paper stars on the boards. In the end, the number of paper hearts was equal to the number of paper stars on the boards. There were less than 200 students. Find the largest possible number of students. We use the method of listing. The first equal number we have is 17. How many students were there? 1, 2, 3, 4, 5, 6. We need the largest possible number of students less than 200. A long way to go. 29, 41. If we continue listing, it will be very long and tedious. We need to find a pattern. 29 minus 17 is 12. Or 17 plus 12 is 29. 29 plus 12 is 41, and so on. So without listing the rest, at least we know a quick way to get the equal numbers. Let's make a table. When 17 is reached, the number of students is 1, 2, 3, 4, 5, 6. When 29 is reached, the number of students is this 6 plus 1, 2, 3, 4, 5, 6, 7, 13. When 41 is reached, is 13, which is all this, plus 1, 2, 3, 4, 5, 6, 7, 20. When 53 is reached, again we plus 7. 53 plus 12, 65. 27 plus 7, 34. Now, even if we use the table and continue listing, although it's better than listing by this way, we still have a long way to go. We are trying to get a number that is close to 200. We are only at 34. So we need to find a pattern again. Number of students. Look at all this number. Remember, we add 7, and so on. So they have something to do with 7. Six is 1 less than 7. 13 is 1 less than 14. 20 is 1 less than 21. 1 less than 28. 1 less than 35. So they have to be related to the multiple of 7. 1 less than a multiple of 7. In other words, we can jump straight away to a number that is close to 200. And that number is 196 because it is a multiple of 7. 1 less than 196 is 195.